Previously, we saw how we can write a makefile to build an application. Now, sometimes you have a makefile that builds a project, and the project consists of not just one application, but multiple applications, and sometimes libraries or other types of binaries or whatever you want your makefile to do. In those cases, typically what you have is one makefile per component that you build. So if you have application A and application B, then you're going to have one makefile for application A and one makefile for application B. But then you also have one top-level makefile that invokes those two other makefiles together. There are, in general, two ways to do that, and that's what we're going to discuss here today. Before we do that, normally if you write the makefile for application A and application B, you write that manually by hand. In this example, we're going to generate that makefile automatically, and we're going to do that using another rule inside of the makefile. We're going to do that to make the tutorial a little bit more complicated and to teach a few more concepts along the way. In this example, the other makefile that we're going to make is here. It's external makefile, and the name is going to be other makemodule.mk, and the target inside of that makefile is going to be hello. So we can run that real quick, and the name is other makemodule.mk, and it created this file over here. What it has is a rule of hello, which prints out hello from other make module, and we can run that easily over here. It's called other make module, and this is the first rule, so it's default, but we can type it in anyways, and it says hello from other make module. We want to invoke this makefile, so we want to do this from this makefile over here. And like I said, there are two general ways to do it. The first way is perhaps the most intuitive way, which is recursive make. And that's exactly what I did over here, where you have a target, let's call it recursive, and the recipe is this command over here, except it's a little bit more complicated. It's a little bit more makey, where instead of using make, you use the variable make, which expands to this, or it expands to user bin make if you use that, or whatever you used. And then we have the same -f, and instead of the makefile name and target, we use the variables instead. So if I run that, we can see that we ran the exact command that we ran manually. We get some extra printouts, which is nice, and you can disable that if you want. I think you can do no print directory. We can put an at the beginning, which will hide everything. What it does is it invokes another make process, and that make process runs the other makefile. This is called recursive make because you have make calling itself. You have make calling another make application. It is the quick and dirty solution. It works, and I do recommend it if you're ever working with an external makefile, in the sense that the makefile you're using or the makefile you're calling is something from another repository. It's from another developer, and it doesn't belong to you. In those cases, it could be useful. And it's especially useful if you're doing it from a top level and you don't keep using recursive make. So the makefile that you call isn't going to call another makefile recursively inside of it. In general, this is not recommended because it leads to a bunch of issues. It slows down your code, your build, and a whole slew of other issues that I'm not going to go into detail here. I do want to refer you to the article Recursive Make Considered Harmful by Peter Miller. This was a bit of an iconic article that came out in, I believe, 1997. And ever since then, we fall back to the other approach, which is non-recursive make. What we do here is we make use of the include directive, and this is similar to the C preprocessor include, where it reads the other makefile and it puts those contents over here. External makefile is this, so it kind of copies and pastes that over here. It's a little bit more complicated than that, but that is essentially what it does. And when that happens, you have the external target declared right here, so you can just call it directly. So I can call hello, and it knows that hello is a valid target in this makefile because it's a valid target in this external makefile here. Or we can call it through the other target that we defined over here, non-recursive, and we get the same output. Non-recursive make is a bit faster than recursive make because you don't have to spawn a new make process. You have the same target in the top level makefile. It does require more work up front, and in this case we have a simple makefile module, so there's not much work here, but in general when you use non-recursive make, you typically have to fall back to using like full paths instead of relative paths inside of your makefile. I believe that it's worth it, but if you're just building something simple, go do whatever's best for you. Overall though, for complex projects, when things get big, you want faster build times, and in those cases there really is a big difference between recursive and non-recursive make. Now with that said, let's look at this include just a little bit closer. And we touch upon something very interesting, which is if I remove the other make module, and then if I remove this external makefile from the recursive dependency list, what's going to happen if I try to build the recursive target over here? It's going to try to invoke the other makefile. And is that going to succeed? Because the file doesn't exist. So we expect it to fail. Let's give it a shot and see. And surprisingly, we see that the other file got created even though it wasn't a prerequisite here. We see this rule being run and we see the other file being created. Why did that happen? The reason is because whenever you run make, it's almost as if you first try to rebuild the makefile itself like this, and then after you've built itself, then you build the other target that you really wanted to build. And when you include another makefile, the file that you included becomes a part of this makefile. And so it also tries to rebuild that other makefile for you. I'm going to say that one more time. If you try to include a makefile and make knows how to build that makefile, so if it has a rule for it with a recipe, then it's going to run that recipe so that it's always running the most up-to-date makefile. In fact, if you're running this on your own, you might see something very interesting where if you actually use autocomplete, so if I type in rec and press tab so that this autocompletes, running that, pressing that tab actually parses through this makefile, and I believe it runs it, and that actually creates that other file, and you don't even see this message. It gets swallowed up. So don't be surprised if that happens, and that's also why if we say, if we try to build the other makefile manually, it says it's up to date. And if we delete it and do it, it still says it's up to date, even though we saw this running. And that's because it ran implicitly. Now, one more note about include is that sometimes you want to allow make to skip or to not give an error if a file doesn't exist. Right now, if you try to include a file that doesn't exist, you're going to get an error saying no rule to make target x.mk. It doesn't know how to include it, so that's an error. If you don't want it to error, then you can put a minus sign just like you do for recipes, and then it's not going to complain anymore. So people do this fairly often if they're using automatically generated makefiles. Especially if you're doing like an auto dependency generation for C or C++ objects. So things like if you're using the -m or mm or mmd or whatever it is from the GCC or Clang output. So to recap, we went over, let me erase that. We went over recursive make. We went over non-recursive make. We discussed how non-recursive is preferred because you don't have to spawn another make process. And perhaps I forgot, but it's also better because you have the entire dependency graph generated inside of one single make process. So it doesn't ever need to rebuild the same target twice. Whereas with recursive make, you typically fall into bugs where recursive makes call other recursive makes, and they might end up doing the same thing more than one time. Overall, prefer non-recursive make if you can. If you can't, then don't beat yourself up about it. Especially if you don't have control over the other makefile, then it is what it is. But prefer non-recursive make. You can also use includes to include other makefiles, and this may be handwritten makefiles or it may be automatically generated makefiles. That's all for this video. In the future, we might go over some more non-recursive make based systems, but if you want, there are some examples online, and I hope you enjoy. Thank you, and see you next time.